So welcome back. This is Madhav. So today we are going to discuss about what is meant by Q and its operation. So let us just get into this Google. So let me just check what is meant by Q. So you can just take this picture. So basically what is meant by Q? Q is nothing but both sides of an array will be open. Then it is known as Q. So in Q, both sides will be open. That means it follows the FIFO rule. That means first input will be the first output. That means let me just copy this image and let me just paste in the pane. Yeah. So here we can just see. So here if we just insert an element into this, then this will just move to till the last one. So this will be the front and this then the next this if we just insert only one element, then the front and rear will be equal. So we can just insert how many elements we want so that it can just move from front and the output will also come from front. So if we need to just check or if we need to just run the conditions of Q and DQ, so NQ and DQ. So NQ will be justified through rear and DQ will be justified through front, which is I will just discuss in the upcoming slides. So let me just continue. So this is meant by Q, and I had already just put the algorithms for this in my desktop. So let me just open this notepad. So here we can just see insertion of value into the queue. In a queue data, enqueue is a function which is used to insert a new element into the insert into a rare position. So here rare gets increased. So here we can just see the front will be stable. That means the front will be only here. The front will be only this. If the front also moves, then rear can't be moved because we need to just increment the value of rear only. So that is we will just discuss in the upcoming slides. So the rear value gets incremented till last, but front will remain the zero. So here the deletion also takes place like that only. So okay, let me just get into this. So here we can just see the algorithm. Check whether the queue is full or not. So to check whether the queue is full or not, we need to just check. Uh, if the queue is full, rare must be double equal to size minus one. So let me just write a code for this. So here we can just open a new thing. So include stdio.h, include onio.h, hash define size 5. So here we are just defining some size. So let me just get into this void insert. So first we are just writing the code for NQ, that means inserting the value. So let me just write for this void insert. So let me just define something. So ARR of so here we are just ARR of size, as we are defined the size as 5, so we no need to just enter the variable value, so we need to just define it as an array of size. Let me just put int, sorry. uh, Let me just put the int. So we need to just initialize the value of front is equal to -1, and also we need to just initialize the value of rear is equal to -1. As their initial position is -1, so we need to just increment the value of the rear, but the front value will be the same. So this is the basic thing for void insert. So let me just see this. if rare double equal to size minus 1, so let me just write the first step. If rare double equal to, sorry, size minus 1, uh, printf stack is full. Let me just check. So the, okay, queue is full. Sorry, I just, queue is full. Let me just give a new line statement so that here the if is completed. So let me just write the else. So let me just get into the point. So if it is full, then displays queue is full. If it is not full, then increment the rare value by 1. So let me just increment the rare value by 1. So rare plus plus. So I just incremented the rare value. So, but we had just missed a point. Sorry. So here we need to just declare one thing here. That is, if friend double equal to minus 1, that means if friend is not getting incremented, as we do not apply any incrementing or adding one to friend. So we need to just give one thing. So if friend double equal to minus 1, friend equal to 0. So this condition is because if front is minus 1, then we may have a chance of getting only one value in the place of front. So for that case, we need to just write an if statement like front, if front double equal to minus 1, then their front is equal to 0. So let me just increment the value of rare. So here I just forgotten to, sorry, we need to just write this thing down here. I just use this as universal void insert. So insert will be same here. So we need to just declare an uh, item. So we need to just insert the value into this queue. So we need to use this item. So by using this item, we can just increment the, include the value into the queue. So here we need to just increment the rare plus plus. So printf, we need to just pass a condition, enter the value to insert. So let me just write a new line. Yeah, now it's good. So let me just use the scanf, and by using this we can just load that value into item. So by using the scanf, we can just load the item. So till here it's everything fine. So if we need to just insert that value in array of rare, as I had said before, if we use this insert function, we need to just use this rare thing. And if we need to just delete that, we need to just use that friend thing, as I said before. So array of rare equal to item. So here, as I had declared the value of item into array of rare, as if array of rare is starting from 0 to 5. So it will just increase the value, and number of times we call, then those many number of times it will just enter the value. If but we need to just write a switch case, right? So if we just write a switch case, then it will just enter the number of times we want. So it should not increase the value of 5. So its maximum size is 5. So here it will just show a message. If it is more than 5, then queue is full. So we need to just do it till here. So I'm just giving a command that uh, element inserted successfully. So I am just giving this thing here without any confusion. Let me just close this. Else is already closed and insert also closed. So till here, no problem. So let's just save this. Yes. So till here, nothing is problem. Everything is just fine. So till here, insertion is just completed. So let me just go into the DQ. That means deletion. So before just going into the deletion, we need to just first display the elements, right? To check whether this insertion is working or not. So let me just use this display thing. So displays the elements of a queue. We can use the following steps to display the elements of a queue. So let me just check the algorithm step by step. Check whether the queue is empty or not. So if friend double equal to array, this may not work many times, as we can say in online sometimes error may occur. So this may not work in every case. So I have just had another alternative for this. So here, very basic alternative, that is void display. So if we just use this void display, so the very basic thing is if friend if front value is double equal to -1, that means it is in its initial state. So if front value is in its initial state, then no element is just inserted in this queue, right? So this is a very basic thing. So we can just write like this. If And we also had another one, if front greater than rear. So front greater than rear is not possible at all. So front greater than rear is not at all possible because the front value is not incrementing, so it will just stay in this. So if the rear value is very less, that means already the front value is 0. So if the rear value is less than 0, that means rear is in its initial position. That means no element is just entered, so we can just use this also. So I'm just writing a statement that is q is empty. That's a very basic thing. So successfully if is just completed. So let me just check the else in the algorithm. So step 2, if it is empty, q is empty. If it is not empty, then define an integer variable I. Set I is equal to friend plus 1. So let me just check. So we need to just initialize a variable of int as int I. So we need to just write else here. So I am just writing else for I is equal to friend. So if we need to just display the things, we are just using this friend. So if I less than sorry for the interruption. So we are just discussing about the step 3. We are just initialized a variable of I. So we need to just display the q of I. So if I is equal to friend plus 1. So I less than rare, I less than rare, I plus plus. So if I is equal to friend, I less than rare, I plus plus. So I am just printing this thing here. Printf. So slash n percentage t. So I'm just using this percentage t. So I'm just printing the displaying the elements. I'm just displaying this array of I. So yeah, now it's okay. So I just successfully just used this display thing. So let me just save till here. So okay, now display is also over. So finally the main thing, that is DQ. DQ is deleting a value from a queue. So we have a very basic three steps. So that is check whether the queue is empty or not. As I had said, if friend double equal to rare, it's not very it's not a case where every time it may be successful. So let me just use the same thing which I'd used with the from above. So void del. So I'm just taking this like void del. So if friend double equal to -1, so this is, or everyone knows that friend greater than rare. I'm just giving a command like printf. So printf uh, q is empty. So I am just printing like q is empty. So let me just close this. So the deleted element is, as I had said before, we need to just use this friend thing. So let me just check the algorithm. If it is empty, then q is empty. If it is not empty, then increment the friend value by 1, and then check whether if it is true, rare, -1. Let me just keep this aside. So we need to just finally print the value of friend, right? So we need to just print the value of friend. So let me just print it. So sorry, the deleted element is percentage d. Let me just give a slash in percentage d comma arr of friend. So I need to just increment the value of friend so that it will just display all the elements by deleting them. So basically deletion in this very basic Q code is to just display the elements, right? So deletion is not a pure deletion, so it will just display the elements. For us, from external, if you just see, it's not a complete deletion. So let me just write this main thing where the whole function is just called. So this is remaining. So let me just take initialize a variable which is called as int opt. Let me just give this clr statement. So let me just use the while loop so that as we need to just use this until the thing is wrong. So let me just write a printf statement. One insert slash slash n uh, display slash n 3 delete. So this is the printf statement, and we need to also just write another printf statement to just tell them or give a command to just enter your option. So let me just write a scanf code here. So percentage d comma and opt. So till here, I think this is fine. So let me just write a switch case as I said before. So switch opt. So number of times we need to just use this, we can just use this options, right? So switch case will be easier in this thing. So let me just write case one. Uh, insert. So let me just write this break. So let me just write the case two. Display. So let me just write this break thing, and let me just write this case three. Delete. So let me just write the break. So finally default. Let me just write the default. Printf wrong option. So for this also break. So finally it's good. So I just completed this program. Let me just first save. Let me just compile. Wow, no errors. So let me just show this code to you as we are just so let me sorry. As I know this time sometimes this software may just crash. So it's no problem. We can just as I just saved it before, you can just open that file. Yeah, Q2 as I saved in the thing. So here while showing in the main while it's showing the options, so let me just put up slash in here. So let me just put a slash in here so that it would look more clear. So let me just run the code. Yeah, now it's fine. So let me just enter an element 6 and another one 8, another one 5 and another one 9. So let me just display the things. So 6, 8, 5. So these are the elements which I just inserted. So let me just delete, delete, delete. Now Q is empty. So here we can just see this is a basic code for Q. Let me just get out from this. Sorry, I just forgot to write exit. So this is basic code for Q. Thank you.